So yeah, hi, welcome guys to your session 4 currently that we are holding today. This is session 4 based on the chapter 7, triangles and its properties. We have been doing this chapter from last 4 days and this will be the fourth and the final session. I hopefully will be covering up each and every question that has been left from our earlier video, that means of exercise 7.3. Then I will be coming back to the remaining concept of this video, which will be the inequalities in triangles and some conditions related to inequalities. Then we will be finishing up with the sums of exercise 7.4 and ultimately we will be having our conceptual videos ending here related to the chapter 7. And next time while you meet me on Monday, we will be having doubt sessions. So I will be happy to clear your doubts there. So I'll see you in your doubt sessions. But for now, let's just start with the video. And since we are beginning with this one, so let's just revise each and everything. So before we do this question right here, let's revise what we had learned up till yesterday. So you guys see, we had understood the various concepts of the triangles and its properties, but we had specifically understood the concept of your right angle, hypotenuse and side. We had used this property, this congruency criteria, when we had been given two right angles such that the pair of their corresponding altitudes were equal, corresponding hypotenuse were equal, and right angles were obviously equal because they were 90 degrees. So remember, hypotenuse has, the pair of hypotenuse has to be equal, right angles, they will always be equal, and a pair of either the perpendiculars or the bases have to be equal. They can be other way also, the figure can be inverted. This perpendicular could be same as your base there. So remember, both of them will be acting as the base or one of them will be acting as the perpendicular. So remember, these were the things that we had understood while we were dealing with the right angle triangles. So remember, in right angle triangles, we have to use this condition. And now let's move forward and start with the second sum. So in this we have what? AD is an altitude of an isosceles triangle ABC. See, this session will be, I guess, around 30 to 40 minutes long. It won't be longer than that because there is nothing much left with this chapter. There are some questions, around 5 to 7 questions or 10 questions. We will be wrapping it up pretty quickly around in 30 minutes. Then we will be having doubt sessions on Monday. So I'll be joining you then. But for now, let's just complete this video. And I hope this will be completed in just one sitting because sums are less. So AD is an altitude of an isosceles triangle ABC. See, I have an isosceles triangle ABC. Let me draw this one. Let's say this is an isosceles triangle ABC and AD is an altitude. So you guys remember what is an altitude? That is a height. So it will be forming a right angle triangle there. So we have two right angle triangles. Let's say this is D point. So ADB is right angle triangle and ADC is right angle triangle. And you have been given that AB is equal to AC. Now, if they had asked you what is the property of isosceles triangle, then how would you be describing the property of an isosceles triangle? Pretty straightforward. You guys will be saying what? That a pair of corresponding sides are equal, or you can say adjacent sides are equal. So either AB will be equal to AC or AB will be equal to BC or AC will be equal to BC. But at a given time, only two sides will be equal. But they have given to you that AB is equal to AC. So these two sides are equal. And we have to prove that AD bisects BC. We have to prove these two sides must be equal. And AD bisects angle A. That means this angle A should be parted in two equal parts. So we have to prove that. Firstly, let's just write it here. Required to prove is what? Required to prove is AD bisects BC. That means we have to prove that BD is equal to CD. Okay. And we have to prove that AD bisects AC. And for this, we have to do, BC. It bisects BC. That means, I have just written it twice. AD bisects angle A. That means angle BAD should be same as angle CAD. We have to prove these two. Now for this, what can you do here? What can you see in this? I can see if I erase this one, if I erase the portion. So you guys see, I have been given two right angle, I have been given an isosceles triangle and there is an altitude in it. So I have two right angle triangles inside an isosceles triangle. So guys see, if these two sides are equal, then the base angles have to be equal, right? Angle B must be equal to angle C. You guys see, there is no such thing as side angle. but there is a thing which is angle side, which is related to somewhat angle side angle, right? So you can prove that theorem and apply it here. So you guys see, if I look at this figure, if I erase everything and let me just draw the figure. So our figure is like this. Let me just draw it. This is the triangle, right? So this is the altitude here. You guys see, this is A, this is B, and this is D, and this is C. Now you guys know, let me just use the ink. So these two sides are equal. That means if they are equal, then this angle and this angle, both of these angles will be equal, right? And this is altitude, so this has to be 90 and that also has to be 90. So you guys see, if I take these two triangles, I can see this angle same as that one, 90, 90 each, and this side is equal to that one. So either we can do it like this, but I have told you that while you are dealing with the right angle triangles, remember, whenever you can, you should use your right angle hypotenuse side theorem. Now in this, can you see a side which is equal apart from your hypotenuse? Obviously you can. I can do too. See, AD is common to both, doesn't it? AD is common. So you guys see, a side, right angle, a hypotenuse, and a pair of sides. All these three parts are equal, then you can say using RHS both of the triangles are congruent. So in triangle ADB and triangle ADC, I can see angle ADB is equal to angle ADC, right? They are equal. And I can see AB is equal to AC, and also I can see AD is equal to AD. Now this is 90 each, this is given, this is also common, right? You guys see right angle, hypotenuse, sides using RHS. Triangles ADB, triangle ADC, both are congruent. And you have to do what? You have to prove AD bisects BC. Now simply you can do this. BD is equal to CD, BPCT. And one more thing, angle BAD equals to angle CAD, BCT. So from 1 and 2, you can say AD bisects angle A and BC. So AD bisects angle A and BC. I hope you guys understand this, or in short you can say AD is the perpendicular bisector. You can do that also. So I hope you guys have understood the case and you don't have any doubt in this, because that will be the solution of the second question. Now let's move forward and see what do we have in the third one. So it is a very important question. Don't try to skip this one. Pay full attention. So you have this third question. You have what? Let's just use the highlighter here. I'm going to use the yellow ink. Two sides AB and BC and median AM. AB and BC and median AM of one triangle ABC are respectively equal to PQ and QR and median. That means this AB right here is equal to PQ. This BM right here, this one is equal to QN, and you have what? And you have this this AM, this height right here is equal to that one. This is median. Don't get me wrong. Sorry, it is median. You guys know what is a median? I've already told you. Median is that line which divides the part that the line which is it falling on into two equal parts. That means this BM will be equal to MC, this QN will be equal to NR. Now you have to show that triangle ABM, this is congruent to triangle PQM, which is this. And you have to show that triangle ABC, this whole triangle is congruent to triangle PQR. Now in this part, you can do it with two ways. Or you can do what? Remember, we have to firstly do it with this method. Firstly, we have to follow up with this, then we have to go on with that. Now, my basic approach, I don't want to confuse you with this. I just know the meaning of median, and you guys already know the meaning of median. So, you guys see these two parts will be equal, right? Like I've told you, these two parts are equal. I know BC is equal to QR, then half of BC will be equal to half of QR, right? because if 4 is equal to 4, then half of 4, that means 2 is equal to 2. So half of that means dividing the equality with equality will be giving you the equality, that means the same answer. So guys, see, if BC is equal to QR, that has been given to me, so I can say BM is equal to QN, can't I? I can say that. So this portion right here is equal to this one. It is straightforward. I know if I take these two triangles now, I can see AB is equal to PQ, I can see BM is equal to QN, and I can see AM is equal to PN. Now side, side, side. So using SSS congruency criterion, I can say triangle ABM is congruent to PQN. First part done. Now if I just don't take anything here, if I just don't use anything, if I just don't use congruent part of congruent triangle here to show anything equal, I simply cannot do the second proof. I cannot simply prove the second part. Now you guys see, if I just go to the ABC and PQR, you guys see I do have AB is equal to PQ, I do have BC is equal to QR, but I don't have any AC or any PR which is equal. I don't have any angles between them that should be equal, and this median won't be helping me much because I'm not so sure that what is the dimension. See, they are equal, but that will be a total different case. We are talking about the entire triangle in which median does not play any role. There is no median right here. We are just talking about the complete triangles. So considering median should be foolish. So for that, I will be doing what? I will be getting to my previous point, my previous proof. I will be doing what? I will be putting these two angles equal. I will be proving that angle BAM is equal to angle PQN CPCT. Now you guys see, if I take ABC and PQR, AB is equal to PQ, angle ABC is equal to angle PQR, BC is equal to QR, side, angle, side. So triangles are congruent and you have your proof. So I hope you guys understand what we are going to do in this. So let's start with the solution now. So solution. I have been given what? In triangle ABC and PQR. AB is equal to PQ, that has been given to me. AM is equal to PN, that has too been given to me. BC is equal to QR, already given to me, and AM is median. Similarly, PN is to a median. So you guys see, if AM is median, then BM is equal to MC, and or you can say CM. Let's just write it accurately. Let's say BM is equal to MC, or I had already written that. Let's call it CM. Sorry. So BM is equal to CM, and QN is equal to RN, because median divides the line into two equal parts, right? So these two things you should be remembering. So I know these two are equal. So let's erase this and come to a proof. So required to prove, you can easily write these two. Now for the solution, or you can say the proof. The proof, in proof we are going to do what? In triangle ABM and triangle PQN, I can see AB is equal to PQ, I can see AM is equal to PN, I can see BM is equal to QN. Given, right? That is the point. They are given, or you can just prove this one, BM is equal to QN. You can say these are proven. So you can write proven also. No worries. You guys see, this will be side, side, side criteria. So using SSS, triangle ABM is congruent to triangle PQN, and we can say angle ABM is equal to angle PQN CPCT, because that will come handy. So that's why we need to have this. Now we have done a part 1. Now we are going to move on to a part 2. So second part, in triangle ABC and triangle PQR, I can see AB is equal to PQ, I can see angle ABC is equal to angle PQR, I can see BC is equal to QR. This is proven, this is given, this is given. Okay, so side, angle, side, triangle, you can say ABC is congruent to triangle PQR, and this is what you have to prove. So hence proved. I hope you don't have any doubt in this because that will be the solution of this question. Now let's move forward and see what do we have now. So let's move forward and start with our next sum. So we have these two sums with us and they will be the end of, I guess, exercise 7.4. So we have this question. BE and CF are the two equal altitudes of a triangle ABC. See, BE and CF are the two equal altitudes of the triangle ABC. Use right angle congruency rule to prove that triangle ABC is an isosceles triangle. Now for this, just bear with me, this question is quite similar to the one that you have already understood in your exercise 7.2. Actually, this is your 7.3. So in your 7.2, you had this sum, right? Let me just draw the figure right here. So we had this kind of a figure in which this was the triangle ABC. This was BE an altitude and this was CF an altitude. Now you have to do what? You have to prove that ABC is an isosceles triangle. So for this, what can you do? You have to use right angle hypotenuse side, specifically RHS. You have to use that. Then you have to make sure that ABC is an isosceles. Now what can you do with this? So see, I can see this is 90. I know the altitudes are equal. So this is equal to that. And if this is altitude and if this is altitude, then this side is what? This side is hypotenuse, right? If I take triangle BFC and if I take triangle CEB, BFC CEB, right? You can see BC here, that is common to both. So if you just want to use your right angle hypotenuse side criterion, then you have to consider these two triangles, right? Now in this, I can see F and E both are 90, they will be equal. I can see BE, sorry, that will be a total different case. Yeah, let's just name them accordingly. Let's say this is BEC and CFB, that will be better. Let's say this is BEC and CFB. Reason being, I'm going to take this triangle and I'm going to take that one, because I have not been given that BF and CE are equal, so we cannot take these two. Although we do know BE and CF are equal, so we will be taking these two. I can see BE is equal to CF. I can see, what else I can see? I can see angle BEC is equal to angle CFB, 90 each. And I can see BC is equal to BC, which is common. Now you guys see this is given. You guys see right angle, hypotenuse and side. Remember, this is your hypotenuse, not that one, because the side opposite to your right angle is your hypotenuse and the side which is opposite, it is actually BC. So it should be BC. I hope you guys understand this, right? So they will be equal. Now let's do what? Let's just prove this one. So I can see triangle BEC is congruent to triangle CFB using right angle hypotenuse side, and we have to prove that the triangles are what? That the triangles are actually the triangle ABC is an isosceles. I can simply prove this one. Angle BCE is equal to angle CBF CT. BCE, which is this complete, CEF, which is this complete. If base two angles are equal, if C and B are equal, this implies AB is equal to AC. This implies triangle ABC is isosceles. Pardon me if it is behind my video here, behind my stream. So what I am trying to tell you, see, if I erase this one, let me erase this, just give me a second. Let's erase this and let me just write it so that you guys can see. So you guys know, you have just proven that angle, let's just use the different thing to show the angles. Let's say this angle, this, you have proved that this angle is equal to that one, right? These two angles are equal. So you guys see, if these two angles are equal, then the sides opposite to equal angles are equal. So this implies AB is equal to AC. Then this implies ABC is an isosceles triangle. So this will be the proof to your question 4. I hope you guys understand this. You can use this proof to solve that sum there as well. So let's move forward and see what do we have in our fifth question. So let me just erase this. So we have in fifth question, what do we have? We have this one. ABC is an isosceles triangle in which AB is equal to AC. Draw AP perpendicular to BC and show that angle B is equal to angle C. Now you have been given that ABC is an isosceles triangle. We have to draw AP perpendicular to BC. Let me just draw this A, B, C, and this is AP. This is 90. Now we have to prove that angle B is equal to angle C. This is exactly the proof of the theorem, the converse of isosceles triangle theorem. You guys see they are isosceles, right? Triangle ABC is an isosceles triangle. So AB has to be equal to BC, sorry, AC. This is 90, this is 90, sides opposite to 90 are hypotenuse. So you guys see a pair of hypotenuse are equal. So you guys see this 90 and this 90 will also be equal and this side is common. Right angle, hypotenuse side, triangles are congruent, angle B is equal to angle C, dt. So this is the proof, which is quite simple. You can easily do this one. Let's just do it now. So what have been given? Given ABC is an isosceles triangle. So can I say this? AB is equal to AC, right? If this is the case, then required to prove angle B is equal to angle C. Now let's take the solution. So I know in triangle APB and triangle APC, let us write this also. AP is perpendicular to BC. In these two triangles, I can see angle APB is equal to angle APC, 90 each, right? I can see AB is equal to AC, this is given, and I can see AP is equal to AP, which is common. You guys see right angle, hypotenuse side, triangles are congruent, and you can say angle B is equal to angle C. So we have just proved this question, the statement that if in an isosceles triangle you have been given a height or a perpendicular, then remember that perpendicular will be actually the perpendicular bisector too. You can simply say this BC is equal to PC also. See, in an isosceles triangle or an equilateral triangle, height is always the median. Remember this, height is always the median. So remember, if the height is falling on a non-equal side, so remember it will be dividing that non-equal side into two equal parts. So that will be the case if you are studying isosceles triangle. So remember this, if you have drawn a height or a perpendicular from the vertex which is sharing the both equal arms, which is the common to both equal arms, so that height will be bisecting the non-equal side into two equal parts, and that will be the perpendicular bisector as well. So this will be it. I hope you guys have understood your exercise 7.3. Now I'm going to start with the inequality concept. So remember, this is a very important concept of this video. So inequalities. So before we had started our congruency, I had told you that there is a concept, there are two conditions which makes sure that a given figure is a triangle. So what were those conditions? That sum of two sides will always be greater than the third one, right? That was the condition. And there was one more thing, the angles. Now these will be the cases we are going to study the inequalities of triangles. So inequalities, we have the very first condition: if two sides of a triangle are equal, then the angle opposite to the longer side, are unequal, then the angles opposite to the longer side is larger. See, what happens here is, if you have been given a triangle, let's just use this one. Let's just take this triangle for an example, right? Now guys, see, I have this example, this triangle ABC. Now what happens is, these three sides are unequal, they are not equal to themselves. Now here you can see the angle B, this angle B looks like an obtuse angle, right? If I just draw a perpendicular, you guys see this is greater than 90, this is obtuse. Now what do? I just took a point C here. Then you guys see this figure will be looking like this, and your angle B will be what? It will be lesser now, because if you put the C here, C dash here, so you guys see if C is there, if I just draw an arc, let's say this is the arc, if I just move further away, you guys see the value of B will be decreasing. See, the C was here, AC was greater, you guys see angle B was greater. Then I did what? I took AC double dash here. So let's say this is AC double dash, and if you join this one, now you guys see AC was greater than AC dash, and angle B was ABC was greater than angle AB C dash. Now what happened if I drew AC double dash? Now AC dash was greater than AC double dash and AC was greater than AC dash. So you guys see this complete angle ABC was greater, but now ABC double dash will be less than ABC single dash and it will be less than ABC. So this is the thing you guys should be using this, or you can just do what, you can just draw this on your paper and you can take the help of compasses. Just try to shorten the lengths and you will be getting the idea that this B will be shrinking and this A is actually increasing. See, it was this, now it is this, then it became that one. So you guys see A is increasing as the value of AC is decreasing, but BC is greater. See, BC here was less. If you move further away, BC will be keeping on increasing as BC dash will be increasing. So that will be the point, inequalities will be happening here. So let's move forward and see what do we have. So triangle inequality theorem. So it states that sum of two sides is always greater than the third side, which is quite true. If that is the condition, you guys see the angle opposite to the greater side is always greater. That will also be the part of this one. So you guys see this states that A plus B should be greater than AC. That means, sorry, C. If you add A and C, that should be greater than B. If you add B and C, that should be greater than A. So all of these things have to be followed. If one of these conditions is not true, then you can say the triangles are that the figure is actually not a triangle. And there is one more thing, sum of all angles has to be 180 degrees. If it is less than 180, then the figure is not a triangle. If it is less than 180, then 2, the figure is not a triangle. The sum has to be actually 180 degrees. So it has to be truly 180 degrees. Now let's move forward and see. So we have some sums with us. So show that in a right angle triangle, the hypotenuse is the longest side. Now we have to show that in a right angle triangle, hypotenuse has to be the longest side. Let's just consider this right angle triangle. So you guys see this will be 90, and let's say this is the values, these are the points ABC. So you guys see this is angle A and this is angle B. Now you guys see in a right angle triangle, you guys know 90 degrees is the maximum angle, a lone angle, right? Or you can just do it like this. Let's just write it like this. So I know in a right angle triangle, you guys see we have what? We have this one, angle A plus angle B plus angle C. That will be what? That will be 180. I know B is 90, so angle A plus angle C, that will be what? That will be 90 only, because 180 minus angle B, that will be 90. You guys see sum of these two angles is equal to B, but what happens is if I take only this angle A is what? It is 90 minus angle C. If I take angle C, that is what? That is 90 minus angle A. So you guys see angle B in short is greater than angle A and angle C. You guys get an idea? We are getting the value of A, which is actually what? Which is actually angle B minus angle C. So you guys see angle B is greater than C. That's why we are subtracting them. Similarly, angle B minus angle A. So you guys see angle B is greater than C. Therefore, we are subtracting C from B. Similarly, angle B is greater than A. That's why we are subtracting A from B. So in short, angle B is greater than both A and C. That does not matter out of those two whether A is greater or not, but we have to verify that angle B has to be greater. So you guys see 90 degree angle is greater than angle A and angle C. So you guys see side opposite to the greater angle is greater. Therefore, you can say AC is greater, or you can say hypotenuse is the greatest side, or you can say the longest side, because 90 degrees is greater than both angle A and C taken separately, but it is exactly same as their sum together. So guys see they individually will be less than 90. So in short, your side opposite to the right angle, which is your hypotenuse, has to be greater, because 90 degrees is the maximum angle in a right angle triangle. So that will be the case here. I hope you guys understand this and you don't have any doubt in this portion. Now let's move forward and see what do we have now. So it is this one. In the figure, sides AB and AC of triangle ABC are extended to points P and Q. See, AB and AC are extended to P and Q respectively. Also, angle PBC, which is this one, is less than QCB, which is this one. We have to show that AC, which is this side, has to be greater than AB, which is this one. Now remember, this is very important question. You cannot skip this one. This will be very important. Now for this, remember this like this. I will be doing what? I will be assuming some values for now. Let's just assume, since I know angle PBC, this angle is less than C. So let's say I'm gonna assume that one as our 88 degrees. Let's just make it a round figure. Let's say it is 80 degrees. And let's say this angle, this is, let me just erase this. Let's say angle PBC is 80 degrees, just to show you the concept, just to explain you the concept. This is not what we are going to actually do here. And let's say angle PCB, let's say it is 100. Okay. Now you guys see, you guys know this is 80 and AB is a line. So if I take linear pair, angle ABC will be what? Angle ABC will be 180 minus 80. That will be what? 100 degrees. So this should be 100. Similarly, if I find out value of ACB, that will be what? That will be 180 minus this 100. This will be what? 80. And you guys see angle ABC is greater than angle ACB, right? This is 100, that is 80. So you guys see ABC is greater than ACB, then sides opposite to the greater angles are greater. So you guys see AC is opposite to angle ABC, therefore AC is greater than AB. Right, that will be the point. So you guys see sides opposite to greater angle is always greater, so that will be the point. Let's just verify one more thing here. So this will be the linear pair concept, right? So that can happen as well. So you can easily prove this one, although that will not be valid because this will not be turning out to be a triangle. See, we have a third angle here and these two are adding themselves to be 80 degrees. This cannot be the case, but this was just for the sake of argument. So if I had taken something like this, let's just do what? Let's assume this is, let's say this is 90, this is 70, and let's say this is 20. Then this will be what? See, 180 minus 90, that will be 90, and this will be what? 180 minus 70, that will be 110. So guys, see, that can happen also. You can easily prove this one. So for that I had taken a wrong example, but that cannot be the case because that will be forming a pair of parallel lines, right? You guys see 80 and 100 both were adding to 180, right? So that was the case of a pair of parallel lines. But in such scenarios, you can use this example also. Let's assume B to be any value. Let's say it is, the one we had taken earlier. Let's say it is 90, or you can do what? Let's take this one, anything other than that. Let's say this is 110. So guys, see, you just have to make sure that both of them are not making an angle of 180 degrees. So you can take this also, 80 and 80. Let's say this is 80 and let's say this is 90. Or you can do what? Let's take this one 70 and that one 80. So guys, see, this will be 110. This will be what? If you solve this one, that will be going on quite large. So you get an idea what I'm trying to tell you. So remember, if this angle is shorter than that one, then its supplement will be greater than that one. So you guys see, if angle PBC is greater than, is less than, PBC is less than angle QCB, then 180 minus angle PBC will be greater than 180 minus angle QCB. You guys see, if you have 10 and you have another value 100, you have 20. If you find out the difference from 100, see, 100 minus 10 will be 90 and 100 minus 20 will be 80. So you guys see, the difference of smaller value is always the greater one. So you guys see, that is the point that I'm telling you. So this implies angle ABC is greater than angle ACB. Therefore, AC is greater than AB. Right, this is what we had to prove. So I hope you don't have any doubt on this because that will be the case here. So let's move forward and see what do we have now. So we have this one in figure. Angle B is less than angle A. Angle B is less than angle A. And angle C is less than angle D. We have to show that AD is less than BC. We have to show that this entire AD is less than BC. Now this is quite easy. You guys see, angle B is less than angle A. That means angle A is greater. Therefore, side opposite to angle A, that means OB, is greater than AO. Right? OB is greater than AO. Similarly, I know angle C is less than angle D. That means angle D is greater. Therefore, I can say OC is greater than OD. Side opposite to greater angle is greater. Now do what? Add these two. OB plus OC, that will be BC, right? OB and OC will be BC, and AO and OD, that will be what? That will be AD. And you guys have this, BC is greater than AD. This is what we had to prove, and that is the solution of this question. I hope you don't have any doubt on this, because that was quite an easy question to do. I hope you guys have understood each and everything. Now let's move forward and see what do we have now. We have this one. This is very important. This sum is very important of this entire chapter. This is always put in your exams. Now you have to do what? You have been given that AB and CD are respectively the smallest and the longest side. Remember, AB is the smallest, CD is the largest, or you can say the longest. You have to show that angle A is greater than angle C, and angle B is greater than angle D. You have to show that this angle A is greater than that one, and this B is greater than that one. Now for this, remember, you have to do what? First, let's join BD also. Okay, now mark the points. 1, 2, 3, 4, 5, 6, 7, and 8. Now you guys know AB and CD are respectively the smallest sides. So if I just compare these two, if I take this triangle, in triangle ABD, I know AB is the smallest side. AB, if AB is the smallest, then AD has to be the greater one. So you guys see this angle, angle 8 will be greater than angle 3. Got my point? This side and that one, if I compare these two, AB is the smallest. I do know this, that AB is the smallest. I don't know anything about AD, but I do know AB is the smallest. If AB is the smallest, then AD has to be the greatest one. So you guys see angle 8 is less than angle 8 is greater than angle 3, right? Similarly, if I do what? In triangle BCD, I know CD is the greatest, or you can say the longest side, right? If CD is greatest or longest, then BC is smaller. Then I can say angle 4, see, angle 4 is opposite to BC, angle 4 is less than angle 7. Got my point? The CD is greater, the angle opposite to the greater side, which is the 7 one, is greater than 4. So you can see angle 4 is less than 7, or angle 7 greater than angle 4. Now add these two. So you guys see 8 plus 7, that will be what? Angle B. 8 and 7 is greater than angle B. This is what you had to prove, right? So you have done half the portion. Now come to the remaining part. Let's erase this and come to the remaining point. Now we have to show that angle A is greater than C. So if I just do what? If I just let's just consider these two. Let's just join this firstly, and this is 1, this is 2, this is 3, and that is 4. Now guys, see, if I do what? If I assume let's just not use that point, let's just not use this. So in triangle ABC, I know AB is the least, right? It is the smallest value. Therefore, I can say if that is the smallest one, angle 3 is less than angle 1, because 3 is opposite to AB, which is the least side. So you can see angle 3 is less than angle 1, or you can say angle 1 is greater than angle 3, considering BC will be greater. Similarly, in triangle ADC, I know CD is the greatest. If CD is the greatest, then angle opposite to the greater side is greater. Then angle 2 is greater than angle 4. Add these two. Angle 1 plus angle 2, you will be having angle A. Angle 3 plus angle 4, you will be having angle C. So angle A is greater than angle C. So this is what you had to prove. I hope you guys have understood this question. This is very important, but an easy question too. For this, you have to do what? You have to join the opposite points. Then you have to take all 4 triangles turn by turn. Then you have to use these two conditions only. You guys do know AB is least and CD is the largest. So remember, if AB is least, then it will be having the smallest value, and each and every other side will be greater than AB. Similarly, if CD is the longest one, then each and every other side will be the least one. So using that, you can easily prove your angles. I hope you guys have understood this question, and this will be the very last sum. And with this, we have just completed our chapter. In this chapter, we had understood what? So summary, I have forgot to put that up here. So let's just write it again. So what we have learned up till now, we have learned triangles, congruency criteria, side, side angle, its related one, angle, side, right angle, hypotenuse, side. But we also learned no angle, no no side angle. There were no such properties like these, right? No side angle, right? Then we had understood the inequality. So in inequality, we had understood that sides opposite to greater angles are greater, and greater angles, so angles opposite to greater sides are greater. So these were the things that we had learnt in our chapter triangles. Remember, this chapter is very important. Each of the things should be known to you. You guys must be remembering each and everything, because we will be using some concepts from chapter 7, chapter 6 in a chapter 8, and coming one chapter 9 also. So you cannot skip any of these two. And I will be having a doubt session later on. We will be having some problem solving sessions in which we will be attempting some questions, practice sessions. Doubt session is available on your application. You can just download that application from our website. You can just have the links there. You can get yourself registered. You can have tons of practice papers. So just, why are you waiting for? What are you waiting for? Just go for it and download the application. I'll see you in the next class. Till then, practice as much as you can. Bye for now.